Okay, here we go. Security Analytics and XDR. My name is Matt. As mentioned, my goal here is basically I'm going to do an overview of technical overview of security analytics at Cisco and our XDR product, our recently announced XDR product. So I'll start with secure network analytics, talk a little bit about that, then I'll talk Cisco XDR and summary. I am Canadian. I do like beer. Those things are featured prominently. Okay. That is a thing. Okay, so accelerating security operations. Why XDR? Why security analytics? Why? So for our customers, a security operations center, the objective is to allow them to execute their OODA loop as fast as possible. So for OODA loop, observe, orient, decide, act, decision-making process that an entity undergoes during combat scenarios. From a security operations standpoint, that is, we need to be able to get all of the right data together to make a decision. Observe in security context, the observation phase usually begins with the arrival of a piece of evidence. Before we had the term IOC, it was just an indicator of compromise, some piece of evidence, something that indicates that there is a breach or a compromise. The security operations process begins with trying to figure out what does it mean to your organization. So a real world example that could happen at a place like this. This did in fact happen to me at a Cisco Live event in the past where I was sitting at a bar and I noticed that I did not have a beer. I did have a beer, then I noticed I was missing my beer. So I began the investigation process. I began to gather some data. I looked down at my table. I noticed there was a trail of drops going away to my left. I went to the internet. I was like, who steals beer? There's a website called beerthievery.com. Do not go to it. It is actually running a crypto miner, but it is a real site. You can go there, and I will make some money. But don't go there. I asked the guy across the table. I was like, "Hey, do you know this guy here on this website?" He said he's sitting right next to you, in fact. And then I looked to my left, and I saw this fellow here with 4 beers in front of him. And so I could rightly conclude that he had stolen my beer, so that I can make a decision and action. So the process: observe. We have an observation. Missing beer, orient, gathering data, doing research, arriving at a decision and conviction. And so that is the security operations process. You have 2 highest level objectives in the security operations process: understanding your past exposure, and then second, monitoring and controlling your ongoing exposure. Those are the 2 things that the board cares about whenever there's a security incident. What does it mean to the business, and is it still a problem? So that is the objective. In order to make that, in order to get that conviction, to actually control, basically understand from that observation to the conviction, you need to answer the questions of who, what, when, where, why, and how. And that is data gathering. And so to accelerate the security operations process, the OODA loop, it is all about getting data into the hands of the analyst and presenting it to them in a way that they understand it. Aligning that against the technology stack, observe, orient, decide, act across the top. You have data input, you have a corpus that makes analytical decisions, or basically prioritize and accelerate the data in the context of the business, and allowing the analyst to make and execute a decision very quickly. And so for us here at Cisco, we have 2 products that fall into the Security Operations Center from an analytics perspective. We have Secure Network Analytics and the recently announced Cisco XDR. Secure Network Analytics, which has been around for a long time, 23 years, going all the way back to when it started at Landcope. Secure Network Analytics is a collector and aggregator of network telemetry for the purposes of security, analysis, and monitoring. It is on-premises appliance with optional cloud assist, and I will walk through what I mean by that in a moment. Basically, network data goes into appliances, they're collected, stored, analyzed, and you can then also integrate it with a cloud-delivered Cisco XDR, which is a SaaS, or as I mentioned, SaaS delivered. Cisco XDR is a collector and aggregator of multiple telemetry sources for the purposes of threat detection and response. The question of what is XDR? XDR is the collection of telemetry from multiple security tools, the application of analytics to that telemetry to arrive at a detection of maliciousness, and finally a response to that maliciousness. So that is XDR. So Secure Network Analytics, XDR.
Sounds a lot like SecureX, or is this the evolution of SecureX, or a different
product? It is a new product, but it is also, you can view it as an evolution, which we will talk to momentarily. Yes, it's an evolution and it's a new product. It's a reuse of a lot of our technology stack to introduce a new product. Okay, so a note about visibility, or a note about telemetry. I break telemetry down into two things: noun telemetry, verb telemetry. In order to construct a sentence or describe what happened, you need nouns and verbs. Noun data are things like device IDs, usernames, IP addresses, things that describe the state of existence of an object. Nouns. Verb data is things they've done: net flow records, firewall logs, process execution details. These are just things that an object have done. You basically want both of those in order to build a story. In order to build a story, you need to first get all of the data, to get all of the words together to make a story. That's data collection. You have data storage, and you have analysis. Analysis is the thing that produces outcomes. Outcomes are the most important objective. So rarely is data collection alone an objective, and storage. Only in compliance purposes like, oh, I need to collect and store all my logs because the government says I do. That is an outcome in that scenario, but otherwise the outcome is what's important. If you want a threat detection, you need to make sure you have the right data feeding your system. Not all the data, it's not about just getting data, it's about delivering outcomes with the data that you do collect. All right, and then so that brings me to Secure Network Analytics. Secure Network Analytics, formerly StealthWatch, is a collector and aggregator of network telemetry. So from a network telemetry standpoint, what does that mean? NetFlow IPFix is the primary data input to Secure Network Analytics. Optionally, the ability to span network traffic to something called the flow sensor, which will produce NetFlow/IPFix for where it is collected by the flow collector. Optionally, you can use something called the Cisco telemetry broker to facilitate the delivery of NetFlow, IPFix, etc. to flow collector. We also have the ability to collect NVM logs from the network visibility module in Cisco AnyConnect, or Cisco Secure Client as it's now called, and firewall logs, and in parentheses that's called SAL. Both of these has asterisks because there is a nuance between how the data is collected and stored when there is a central data store versus a single appliance flow collector. So you have options to scale the system horizontally. You can add multiple flow collectors. We have recently introduced something called the central data store that allows you to separate collection and storage into multiple, either physical or virtual appliances. The data store is a high performant data redundancy system as well, meaning if you have 3 nodes in your data store, you have data redundancy. Any one node can fail, you lose no data. You want longer term storage, you add more nodes at it, you have more storage. And then manager. The manager is a virtual machine or physical appliance that manages the deployment, and this is the main UI that you interact with. Threat intelligence feed, configuration, and identity information from the Identity Services Engine come into manager from pxGrid. From an analytics pipeline, and I'm going to go a little bit deeper into some of these analytics engines in a couple slides. Just from a location standpoint, analytics run in varying locations. There are 3 major detection engines that run on the flow collector, plus reports around network visibility and policy analytics, and I'll talk to those momentarily. Those run on the flow collector. The manager has something we call the analytics node, which runs against the central data store. That's a relatively new feature that is attempting to run against a enterprise-wide data set as opposed to data sets isolated on individual flow collectors. There is cloud assist options. So optional cloud assist, you can turn on something called global threat alerts, which is a multi-layer machine learning engine that is actively profiling the world, so to speak. This is where we do what we at Cisco have marketed as encrypted traffic analytics, which is the ability to uniquely identify threats without decryption, or uniquely identify singular malware instances without decryption. And then something called XDR Analytics, XDR Analytics. And XDR is our new product, which is the second half of what I'm going to talk about today. So from an analytical outcome example, the main objective behind Secure Network Analytics is around threat detection. That's our objective. We collect and aggregate data to deliver or detect threats using an analysis of baseline or an analysis of network behavior to infer the presence of a threat actor. The word infer is important. We don't actually necessarily know it's bad, we just know it's weird, or we know that the network behavior is not something that we should expect. Quintessential example that I often use are things like high traffic type alarms. Suddenly this host has high traffic, either in comparison to his baseline or against thresholds, and we're just like, he has high traffic. We have made no conviction of that. We don't know what the high traffic means, we just know it's weird, or it's something that you should look at. Network visibility, analyze network behavior to design, implement, and validate network operations. Pretty common story of being able to look at the fact that we have full visibility east-west throughout the network to understand that your network is operating as you would expect it to. And then security policy, something that I am, or policy analytics, something that I am very passionate about, is using the ground truths of the network that we have inside of the product set to actually analyze, design, implement, and validate your security policies. And I have a screenshot of that in one slide to talk through what I mean by policy analytics. Now, a note about data and analytics before I get into some outcomes and talking about the analytical engines more in depth. Analytical outcomes are driven by data. What that means is if you say, I want a very specific type of detection or outcome, you may need very specific types of data. If you say something like, I need to detect communication to these known botnets or command and control servers, you need a threat intelligence feed that maps to those known command and control servers. Similarly, there's a lot of other examples, like I want to know if somebody is tunneling not HTTP over port 80. You need a deep packet inspection device to report the application details in that packet path. Now that gets to not all data exporters are created equal. Every device in the network supports what basically can report something slightly differently based on its features, functions, and locations. An access layer switch knows the MAC address of a device of something connected to it. A distribution switch can at least say what input interface, output interface it went through. There's deep packet inspection devices. Firewalls, for example, can add application information. Many routers or switches have NBAR on them these days. You can actually get application details there. Firewalls change data. They will do NAT translations. They need to be able to report those changes in the flow records. Every device supports NetFlow differently, and it's entirely possible to configure it differently on most devices as well. So there's lots of caveats on that. What, as best as possible, Secure Network Analytics attempts to capture unique data. The industry term, which I dislike immensely, is deduplication. The reason I dislike it immensely is that is exactly not what we do. When I say unique data, everything is unique. If nothing else, every exporter reports the interfaces that the flow went through. We capture that information. We don't discard it. Deduplication in the industry sense is every flow record is basically the same 9 fields. In the real world, that's not true. There's a lot more data in every one of them. So there is consistent data, the 5-tuple IP address sets, timestamps, etc., byte counts, packet counts. Those are relatively consistent hop by hop through the network. Using that, we can find the unique data, interface data, NBAR data, NAT translations, etc., and put them all into a single database entry inside of Secure Network Analytics. That is, this processing is one of the major value propositions of the product. It is actually extremely complex when you start digging into how it all operates. And the value of that data set is, in my opinion, quite unique, very special. And once we have that database and be able to collect all of the unique data across every hop, you can start to do very interesting things, which is why to get to policy analytics. Policy analytics. This is a screenshot from Secure Network Analytics of what we call the TrustSec or adaptive policy, if you're in the Meraki vernacular. matrix, you have source security groups down the left, destination security groups across the top. This matrix is reporting traffic between security groups, which that means what we've seen from the network. So green means there is traffic between two security groups. Red means there is traffic, and according to the policy that's in the Identity Service Engine, there is supposed to be a deny IP configured between those groups. Blue means there is traffic and a ACL other than deny IP or permit IP is between the two security groups, which would be a custom a custom policy is what we called it, meaning it's not permit or deny. Orange triangles, which appear here, are an indication of a potential policy violation, meaning we've also pulled in the security groups or the SGACLs that are in place between all of the different groups, and we are analyzing the traffic that we are seeing against the policy that should be in place. So if we see an orange triangle here, for example, there is bidirectional traffic between the employees and production. This is production servers, I believe. Production servers security group, where the policy basically is indicating that should be deny IP. So we see round trip traffic, but we should not have, according to the policy. Okay, so from a threat detection standpoint, there are multiple analytical engines that run on Secure Network Analytics. I break them into on the box and in the cloud. And so on box, there are three major analytical engines that have been around for a very long time. We have one that's relatively new that we're experimenting with. And it's actually from a network detection standpoint, it's actually code redundant with the network detections that are running on XDR analytics. That's a long story on how we're attempting to use. We do a lot of research on the cloud side. We test out new detections up here, and we try to push them down on premise as we develop new detections. So starting with SNA, we have on the box custom security events. These are user-defined policies. User creates an alarm that fires when there is a certain flow condition. Core events. Core events are the behavioral algorithms. There are about 98 that are running on the system. So for every network connected entity, which is either an IP address or a group of IP addresses, which is a label on an IP space, we baseline that behavior of that host. Run these 98 algorithms and build them up as part of the behavioral profile of that host. They are statistically anomaly detections, and they are threshold or policy-driven detections. So for every one of those algorithms, we will watch for a given set of behavior. If the behavior occurs, we observe it, we give the host points, so it's part of the model. If the host exceeds a threshold, which is user configurable, there's an alarm, or if it exceeds or deviates from baseline behavior outside of an acceptable range, there's an alarm. Relationship events are similar in nature. However, instead of running against a single host, they run against a relationship between two hosts or a set of hosts. Relationships are really useful for monitoring traffic presence absence conditions or anomalistic volumes of traffic between hosts or groups of hosts. Cloud enabled from a threat intelligence feed, that's pretty straightforward. Alarms against known command and control servers, bogon, Tor entry and exit nodes. Global threat alerts. This is a complex multi-layer machine learning engine that does malware classification on, basically that malware classification really means TLS fingerprinting, client server application. So we build up fingerprints for known sets of malware out in the world, and we identify when they exist. This is really good for detecting the unknown knowns, meaning if you have, or let's say we know about 10 command and control servers belonging to a very specific malware family out there, it is incredibly good at identifying number 11. That also means it is exceptionally well at identifying all of the otherwise unknown Tor entry and exit nodes. Is a very good example of use case. So we often find like Tor entry and exit nodes. If you're on a network that blocks Tor, you're not really blocking Tor. You can still connect to Tor. This finds those, when the connection occurs fairly quickly. And then finally, XDR analytics, which I will talk to significantly momentarily about XDR analytics. This is their ability to basically extend detections. And one of the very new features that we have is something called attack chaining or alert chaining, which I will demonstrate if I don't talk too much. So Cisco XDR. Cisco XDR is a collector of telemetry from multiple data sources. We analyze that telemetry to detect threats. We extend and enhance and prioritize the threats. So and then facilitate response. So I'll talk through it, but it's basically starts with data either from the network or endpoint or whatever else we have as an integration surface. We run analytics to surface what we call it an incident, which is made up of multiple detections from downstream products. And then we continue to enhance and prioritize accordingly, and then drive into a response. In order to actually do extended detection response, you need integrations and data from more than one source. So previously I started talking about network analytics. Now we're going to extend network analytics with analytics of multiple data sets. For XDR, especially in the security operations world, tended to start from an endpoint-centric perspective. We have an endpoint product, Cisco Secure Endpoint. We also fundamentally believe that the network is centric to security operations. We actually polled a lot of our customers as well. Actually, we did a double blind polling. They didn't know who was asking. We didn't know who was being asked. And the data that we got back indicated that network data is the second most important set of data to a security operations center. So for our strategy, we were like, let's go in. We're going to have endpoint-centric, where endpoint detection response is foundational to XDR, but also network detection and response is foundational to XDR. So we built in native to Cisco XDR, a very robust network detection, or set of network detection capability stack. In fact, the network detection stack, which I now call XDR, I had the ability to analyze additional data sets, something that we now call XDR Analytics. It can be previously referred to or known as Secure Cloud Analytics, which is an evolution, not just of, so when we get to XDR, it's an evolution not just of SecureX, it's also an evolution of multiple other products that we have, all merged into one.
Question.
Yes.
I imagine you're using all of your resources for threat intelligence, but you did mention a little bit about baselining. How long does it typically take to create this is what normal is in my network?
So it varies by algorithm. So some algorithms have 0 days of baselining behind them. Some have the most common set to get to the majority of our algorithms in terms of baseline is about 7 days. Some go to about 14. The longest, of which there's a handful, go to about 36 days. And that's just for the purposes of trying to, just keep the system to be as efficient and less noisy as possible. So one of the newest ones that I like, it has 36 days, and it's actually it's an abnormal ICE user. It actually just went into production a couple weeks ago, and this one takes 36 days according to the rules. And that just means that it will trigger when a user logs into an asset that they've never logged into. So we had to establish a long baseline of how, actually more specifically, there's a user that almost always logs into the same device and somebody else now logged into it. So it just takes time. So that's the long one, but there's some that are like 0 days.
And then if you know that you're going to have weird activity for a certain span of time, is there a possibility to say, don't use this as my baseline, within my baseline?
The baseline is going to continue to evolve through time. It's a rolling baseline. So to prevent from learning bad behavior, it's going to update itself. So for most of the rolling baseline, it's about a 30-day rolling baseline. So it's like 7 days to converge, but it's going to continue to update through time over a 30-day period.
Yeah, when you start talking about baselines, I work in higher ed, and what happens, in the middle of a semester or the beginning of the semester is vastly different when nobody's on campus. So
certain customers that I work with, financials are a good example. They have once a quarter, very important backup. Understanding those things and being able to understand those baselines. So, and that's why there's sets of either thresholds as well as deviation from normal. And so you can also adjust how much of the deviation you are allowed. Like, do you want to be 1, 2, 3, standard deviations away from the mean, right? It all really depends.
You mentioned not being too noisy, so I'm curious in what you have in place to reduce like false positives, but also ensure false negatives are hopefully zero.
Yes, absolutely. So the way that works is we have a basically so in the analytics pipeline we go raw telemetry, build up an analysis and normalizations. That's their data ingest from the model perspective. It's observations to alerts to what we now call alert chaining. And so it starts with, it'll start with observations. So we'll build up an observation, say like we saw a user logon event, for example. And so then we build up an understanding of what is the most common sets of user logons for this particular host. And then as the movement from observation to alert, there is a whole level of probability that this is going to be a security event logic that is applied. So like it is easy to make a lot of noise in this type of system. And what we do is basically is like how probable is this actually to be a security event given everything else that we understand about the environment. So there's a lot of logic to basically try to move from just an observation, we saw this occur, to there's an alarm. So there's layers of it, and then alerts are things that we feel like the user needs to know about it, but the observations are still present in the system. So basically, like there's raw telemetry, there's a layer of we've seen things happen, there's alerts of we think you need to look at the things that have happened. Then there's attack chaining, which is where a relatively new feature that is attempting to put alerts and/or observations that seem related together into a more of a super alert or an incident view, as we call it, and so that's putting several different related alerts together. So for example, in this particular attack chain, we had 8 different alerts that occurred over a period of which looks like 6 months. The original detection occurred way back in January. That was an internal connection alarm. An IDS notice, which is there's suddenly a lot of IDS events for this particular host, which occurred way back in February. Malicious processes that have been executed on this host relatively recently, as well as an LDAP connection from a suspicious process that has occurred. And this is the abnormal ICE user alarm that has occurred here. So this is basically and then also we link them on the MITRE TTPs now, so we can actually put together a whole view of, that's why we call it an attack chain, of from the initial persistence through impact, execution, et cetera, of the behavior of this particular host. And then promote that over into Cisco XDR, where we can fully run through the complete incident response process. And if we look at, say, the detection, I think I had this in another tab, so it would, nope. You'll notice that I am now powered to my phone, so I make no promises on this working, because we're on like whatever floor this is and you get 1 bar of signal. Okay, so then it's putting together the whole attack view and all of the related components that are related to a single detection. So it starts with so we have singular alerts that we try to aggregate up to one giant attack chain. We then enrich against anything related to that alert and come up to a full display of what happened with that detection. And with that, I am, according to this, at 5:46 p.m. So, but that says I have 1 minute. So that's my demo. I'm open to questions.
Just briefly, you did on one slide. It did say that an additional license required. I'm curious because I know your other security product was like, if you have a security product, you have this. But this one,
right? Yeah. So Cisco XDR as a product is a licensed product. So you do have to buy a license to get XDR. That's the